This is a diagram showing what could be absorptive cells in the small intestine, and this area here is the lumen where the digested food would be. These are the absorptive cells themselves, so this inside here would be the intracellular fluid, or ICF. We have some interstitial fluid here, and then we have plasma inside a blood vessel. So this diagram illustrates several ways that solutes can be moved across the plasma membrane. So let's start with what's going on at step number 3 here. So this is what we call the basal side of the membrane, and this is what we call the apical end of the membrane. So at step 3, we've got two different solutes being moved in opposite directions if you look at what the arrows are doing. And in this case, we actually have ATP being directly hydrolyzed by this transport protein. And because the ATP is being hydrolyzed directly by the protein that is moving the solutes, we call this primary active transport. And the solutes that are being moved here are potassium, which is being moved into the cell in exchange for sodium ions that are being moved out of the cell. So let's put a sodium over here, and we can indicate that the purple ball is still sodium over here. So as a consequence of the sodium being pumped out of the cell, and we call this protein the sodium potassium ATPase, as a consequence of the activity of this transporter, the concentration of sodium inside the cell is always really, really low. So I'm going to draw sodium quite small here, and much lower in concentration than, say, inside the lumen here. So I'm going to put a few more sodiums here to indicate that the concentration of sodium is much higher in the lumen and higher here as well. So this is important that we have created what now is called a sodium gradient, higher sodium outside than inside, because this gradient now creates a source of energy which allows us to move another solute into the cell against its concentration gradient. So here at step number 1, the process of secondary active transport can occur. And with secondary active transport, the transporter protein allows one solute to move in with its concentration gradient, so from high to low concentration, and that's sodium, while a second solute uses the energy in that sodium gradient to move it to move against its concentration gradient, and that is going to be glucose. So glucose is now moving into the cell against its gradient, which means it's going from low to high concentration. It's glucose. So now we have glucose building up inside the cell. And now that there's much more glucose inside the cell than outside, because as soon as the glucose leaves the cell, it's picked up in the blood. And so because the glucose moves from high to low concentration, we call that process of movement diffusion. And in this step 2 here, we have facilitated diffusion happening because a transport protein is necessary, or carrier protein, because the glucose is not soluble in the plasma membrane. So at step 2, we'll call this facilitated diffusion. So we have a solute following its concentration gradient, facilitated. And It's facilitated diffusion because it requires a transport protein to cross the membrane. If it didn't require any type of transport protein, we would call it simple diffusion. So here's an example of where we could have simple diffusion. So all of the glucose that's absorbed as it leaves these intestinal cells, it moves through some interstitial fluid into the blood, and then it's going to get transported to working cells that need it. So here's a cell with its nucleus, and the glucose is going to enter this cell by, you guessed it, facilitated diffusion. So let's put a number 2 on there. So that's for glucose. But the other thing that gets transported in the blood, or one of many other things that gets transported in the blood, is oxygen, as you know. And when oxygen enters the cell, as we've already seen previously, it enters by the process of simple diffusion because it's small and lipid soluble. So simple diffusion. I'm just going to abbreviate the word diffusion there. So you could also take your notes template that you have for this and add to this the process of transcytosis, where solutes enter the cells by endocytosis, so coming in the apical side, move across the cell by transcytosis, and leave by exocytosis. So look that one up in your book and add it to your diagram. So to summarize the types of transport, then, any type of active transport is moving solutes against their concentration gradient. Diffusion is moving materials with their concentration gradient. And the difference between primary and secondary active transport is where the energy comes from. So for primary active transport, ATP is directly hydrolyzed by the protein that is also moving the solutes. With secondary active transport, the energy comes from a solute concentration gradient that was created by primary active transport. Facilitated versus simple diffusion. Diffusion means the solutes are following their concentration gradient, going from high to low. With facilitated diffusion, like with glucose, we require a carrier protein because glucose is not soluble in the plasma membrane. With simple diffusion, like with oxygen or carbon dioxide or steroid hormones, they're lipid soluble. They just move directly through the plasma membrane and a protein is not needed. So make sure you practice drawing this on your notes template and explaining it to your friends so that you can get all of these transmembrane trafficking modalities clear, because this is really, really important for understanding what's going on in the intestines and the kidney and many other areas of physiology.